In this lesson, we're going to learn one final trigonometry tool, which is the cosine law. So by the end of this lesson, we should be able to use the cosine law to solve for side lengths and angles and triangles, as well as use the cosine law to solve problems. So we know that if we have a right angle triangle, we can use the following theorems. We can use Pythagorean Theorem, so a squared plus b squared is equal to c squared. And we can also use the trig ratios, which we can remember them just using SOHCAHTOA. So those are our two tools that we can use if we have a right angle triangle. And if we don't have a right angle triangle, we can use any of these tools. We can use the sine law and the cosine law. These will work for all triangles. So we're familiar with the sine law. We did that in previous lessons. Cosine law is new for us. So a reminder, it will work for any triangle, including right angle triangles. However, these two tools are much simpler. So if we can, we're going to use these guys. Taking a look at the cosine law, we can see it's made up of three different equations. It's just rearranged in the same pattern with side lengths on the outside and our angles in the inside of the equation. So we're going to label our triangle the exact same way we did with sine law. We'll use big A and little a, big B and little b, etc. So the uppercase letters will be on the angles and the lowercase letters will be on the sides. So if we can use one of the tools that we have for right angle triangles, we're going to use it because they're much faster. Also, sine law can be a whole lot faster than cosine law. So if we don't have a right angle triangle like we don't have here, we can try using sine law. In worst case scenario, if sine law doesn't work, then we're going to use cosine law. So let's check if we can use sine law here. So we're asked to find angle B. So let's we're asked to find side B. So let's label the rest of this triangle. We can make this angle B. Maybe we choose to make this angle A. Here's little a, side A, and we can choose this as angle C and this is little c. So if we were to use sine law, we would write out the sine of our angles over the corresponding sides as a ratio. So let's go ahead and write them out. Let's write the ratio for A. So our ratio for A would be our little a, which is 20, all over the sine of our angle A, which we don't have. Note we can't find either of these angles because we only have one angle in this triangle. And let's write our ratio for B. We have a little b over the sine of 52. So we're definitely going to need that ratio. And then let's do the same thing for C. We have side C at 16 all over the sine of angle C. So now we know we would choose two ratios. One ratio has to have the thing that we're looking for, so that's B, and one ratio has to be complete because we're only going to have one equation because we can only solve for one unknown. This ratio here is not complete. We don't have a matching angle and side, and either is this one. So in this case, sine law is not going to work, which is why we need a second tool for these cases. So we can quickly tell from a triangle if we can use sine law if we have a matching angle and corresponding side, because then we know we're going to have a complete ratio. So 52, we have angle B, we don't have side B, not a complete ratio. Angle A we don't have, we do have side A, and side C we don't have angle C, so we don't have a complete set, which is why we can't use sine law. So we're forced to use our last case scenario, which is cosine law. So we're looking for side B. So for cosine law, we got to pick between these three equations. If we're looking for little b, which of these equations do you think would be easiest for us to use? Well, take a look at equation number 2 here. Little b is already isolated for, so this is going to be really easy to solve for little b. So I'm going to pick equation number 2 and just write it out. So we have b squared is equal to c squared plus a squared minus 2ca times the cos of b. Just writing out that second equation. And let's fill in what we know. We don't know what little b is, so we're just going to write little b. We do have little c, 16 squared. We do have a, 20. And we're going to write minus 2 times c. c is just 16. A is 20. And then we have the cos of big B is 52 degrees. So now what we have here are a bunch of like terms. This is just a constant, this is also a constant, this is also just a big constant number. So we can plug this all into our calculator, but I only want to round once to reduce the rounding error. So let's get B by itself first by square rooting whatever is on this side and square rooting this guy too. We don't have to do the positive or negative root because this is a distance, so it can only be positive. So our b is going to equal the square root of all of this. So try that in your calculator. So if you put that on your calculator, if we're going to round to the nearest tenth, we are going to get 16.2 approximately meters. And there is our final answer. Is this a reasonable answer for this? This is not to scale, obviously, but 16.2 is reasonable given the angle and the other two dimensions. Let's try another example. So in this example here, we have a triangle and we're given 3 side lengths and we're asked to find the measure of angle A. So because it's not a right angle triangle, we know we have to use sine law or cosine law. So let's first label this triangle using uppercase letters and lowercase letters. So since we already given angle A, let's call this little a. And maybe we choose to make this big angle B, and we can make this side B, and then we'd be left with choosing the bottom right as angle C, and we can make this as side C. So if we can use sine law can be a lot faster, and so let's use it if we can. But we don't have any matching sides and angles or corresponding angles and sides. So our angle A obviously we don't have, but we do have side A. But we have side B, no angle B, and we have side C, no angle C. So if we were to write out sine law, we wouldn't have a complete ratio. Therefore, we can't use it. So we're stuck with using cosine law. So we have to find angle A. So let's figure out which of the equations of cosine law would work for this. So we've got 3 different options. We've got this guy, and this guy. There's only one time where an angle appears, which is at the very end of the cosine law equations. And this is the only equation that has angle A in it. So I have to choose this equation here. Now this is going to be a little bit harder than the previous example because we were looking for a side length before. Side lengths are already isolated for us. Angles are not. So we're going to have to do some mathematical manipulation. We're going to have to do some solving equations to be able to solve it. So let's start off first by writing out the cosine equation that we're going to use, which is a squared equals b squared plus c squared minus 2bc times the cos of a. And let's fill in what we do know. What we do know is we know what a squared is. That's just going to be 30 squared. We know what b squared is. It's going to be 38 squared. And we know what c squared is. It's going to be 26 squared. Then we have minus 2. Maybe I'll just put this in brackets. 38 squared, 26 squared, 30 squared. We have minus 2 times b is 38, times c is 26, and then we have times the cos of a. Now we could start putting these numbers into the calculator, or we can use the calculator just one time. So whatever works for you. But before we use the calculator, before we move terms around, what are like terms here? This number is just a constant value. There's no variable involved at all. How about this guy? Also a constant. There's no variables involved. And how about 26 squared? Also just a constant, just numbers. So we can confirm that these 3 here, 1, 2, 3, are all like terms that we can add and subtract together. How about this guy here? Is this a constant? It's not. It's a coefficient because it's attached to cos of a. So one huge mistake we could make is to put all of this into the calculator and just tuck cos a beside it. That's not going to work because this is a coefficient. That would be the same as saying 2 plus 2x is just equal to 4x. No, because 2 and 2x, those aren't like terms. 2 is a coefficient of x, and this 2 is a constant. So we can put 30 squared in the calculator, 38 squared, 26 squared in the calculator, or we can just start collecting like terms, and we want to move everything over to the left to get a by itself. So if I were to rearrange it, we have 30 squared on this side, and then bring 38 squared onto the other side, so it becomes minus 38, as well as 26 squared. So I'm going to take minus 38 all squared, minus 26 all squared, and we would be left with, on this side here, this negative 2 times 38 times 26 is equal to times the cos of A. So we can check what this is in the calculator right now if we'd like to. It's going to work out to negative 1,220. And we can also check what this guy is going to equal to. What is this coefficient of cos A? It's equal to negative 1976 times the cos of A. So let's continue to get A by itself. We can get rid of this number by just dividing by it. So we can divide by negative 1976 on this side, divide by negative 1976 on this side. These two will cross out. And how do I get rid of the cos now? Well, we have to apply the opposite of cos to this, which would be cos inverse. So we would take the cos inverse of whatever this number works out to, 1,220, divided by negative 1,976 is equal to A. Do not put this in the calculator first and round it and then apply cos inverse. Put it in all together. So we're going to check what this divided by this is and then apply cos inverse to it. And that's going to give us as exact an answer as we possibly can get. And we get an answer of approximately 51.87 degrees. And we are done.